So I got the recording going. Welcome everybody. The new lesson is 3.2. We want to open it up with questions about 3.1. Welcome, Christian. .1 questions. I'm going to pass one on to you that I got from one of the students in the session already. Welcome, Taylor. A question that was asked earlier was a problem like number 37 for today. The 33, 35, 37. What did those directions mean? Okay, so I'm going to show you that one. This is number 37, and we're going to talk about, and that was, welcome to Nathan. Welcome. So we're just going through one question about the assignment for 3.1. Number 37, that 33, 35, 37 had different directions. So here the whole idea was, instead of giving you a function and a point and asking you to find the equation of the tangent line to that curve at that point, the only difference is this time they gave you, as you can see here, they give you the equation and then they give you a line that the tangent line is parallel to. Okay, so that means a little bit different strategy. So the first thing I did is took the equation of, that thing that we're parallel to, and I solved it for y. So now I could see what slope I need to have, because the slope of that line is -1/2. That tells me that must be my slope. Okay, so the only difference is, after we find the derivative of the function, instead of saying what's the derivative at and then plug in the x coordinate, I don't know the x coordinate, but I do know that that slope, the tangent line that the derivative will give us, is equal to -1/2. So anyway, there's a conjugate derivative that has to be had. So my question is, how many, hopefully you arrived at a derivative that you see in the blue circle. The derivative, and let me know if you want me to go through that. But I came up with this derivative, -1 over x times 2 times the square root of x. Does anyone need me to go through that? So that's basically, this whole section in here where we use conjugates and then simplify and finally cancel h's, and then I come to the derivative. The only thing different is now taking that derivative and setting it equal to that slope I showed you earlier of -1/2. That allows me to solve for x and come up with the fact that x is equal to 1. Okay, so x is 1. Now we go back up to the top and look at the original function right here. If x is 1, what's f of 1? 1 over the square root, it's 1. So now I finally know the point 1, 1. Okay, so now we can come back, take our derivative right here, and find what's f prime at 1, because we know it's at the point 1, 1. And I get that for my slope, -1/2. So now I know the equation is y equals -1/2 x plus something, and then you substitute in the y coordinate and the x coordinate. You can solve for the b. So y equals -1/2 x plus 3/2 would be the final solution. So the only difference here is, instead of them giving you a point, they gave you a line that we were parallel to, and it just caused a little slightly different technique for finishing up. So anyone want to make a comment or Does anyone need to see the detail on this one? If so, I would be happy to show it. Not hearing anything, so what we'll do is we'll move on. So here's the lesson today, 3.2. You're going to love it because although now 3.1 was a very important assignment. Those long derivatives are extremely important, and I can guarantee you that will be on the Chapter 3 test. So if you had, I'm not saying that as a threat. I'm just saying if you had any trouble with that, don't think it's going to go away. We need to figure that out and get that straight, or ask me or something, okay? Because that's a very important process. Now, despite that, those derivatives are long, and it's going to be wonderful to have also a shortcut, and that's what today is all about. Rules for differentiating, which will make derivatives much shorter and much more efficient. The good news is they work well. Yeah, they're nice and simple, and they're fairly easy to adapt to. The first rule is called the constant rule. And that simply says this. If you want to take the derivative of any function that's a constant, here signified by the letter C, this is simple. The derivative is 0. There's a proof here. I'm not going to go through it right now, but let's apply it. Okay, so any constant. So here we have y equals 7. That's certainly a constant. What's the derivative? 0. The second one, f of x equals 0. 0 is a constant. Derivative, 0. S of t equals -3. -3 is a constant. Derivative, 0. Y equals k pi squared, where k is a constant. Obviously, pi is a constant. So I have a constant times a constant, which is a constant. The derivative is 0. So if you have a constant with no variable and you are to take the derivative, the result is 0. Okay? Next one is, I don't know, probably my favorite. It's called the power rule. And the power rule says if you have x to a power, all you have to do to take a derivative is take that power, multiply it times the entire quantity, and reduce the power by 1. Let's look at the examples right here. Part A. F of x equals x cubed. That's a exponential number. Take that exponent 3, multiply it in front of the function, and reduce the power by 1. So x cubed goes to x squared. Derivative, 3x squared. See, we could use a little bit more size here. Okay, the second example. The cube root of x. How are we going to write that as an exponential? Oh, yes, that's x to the 1/3 power. So your algebra skills come into play. And how do we take the derivative of an exponential x to the 1/3 power? Take the power, multiply it by the whole expression, reduce the power by 1. So 1/3 multiplied out in front, and then reduce the power by 1. What's 1/3 minus 1? -2/3. So there's the derivative, 1/3 x to the -2/3. Now, our book, rightly so, says you're never done when you give an answer with a negative exponent. So the last step you see there is just removing the negative exponent. So what is x to the -2/3 power? How can I make that positive? By moving the x to the 2/3 down to the bottom. So this is the kind of, in the box, that's the kind of solution you will see in the back of the book. And we're going to count that. So that's your final answer. The last one, x to the 1 over x squared. How do you write that with just a simple exponent? X to the negative 2 power. Now follow the power rule. Negative 2 multiplied by the quantity. Take x and reduce the power by 1. Negative 2 reduced by 1, negative 3. Negative exponent, so the final answer is make the exponent positive by putting it in the opposite floor. By the opposite floor, I mean if it's in the numerator, move it to the denominator. If you had a negative exponent in the denominator and you move it to the numerator, that would change the power to 0. Okay. Questions? Okay, we now go to the constant multiple rule. So now when a constant was by itself, y equals 10, 10 is by itself, then the derivative is 0. But what if the constant is a coefficient, a number out in front? Then you basically ignore the coefficient, keep it there, don't do anything with it, and just take the derivative of the rest of it. That's what this says here. It says if c is out in front, just leave it out in front and then take the derivative of the rest of it, the f part. Example again. So 5 over 2x cubed, let's say that's our function. If that, so that's really the same as having 5 halves multiplied by 1 over x cubed. You know, just pull that constant out to the left. And why is it written as x to the negative 3? Because x was in the denominator. Now we've got a format here. Now we've got a format here which is ideal for the power rule. Leave 5 halves alone, take negative 3, multiply it by the entire quantity, negative 3, reduce the power by 1. From negative 3 it goes to negative 4. Now just simplify. What's 5 halves times negative 3? Negative 15 halves. What's x to the negative 4? X to the positive 4 on the bottom. Let's go down. Let's do part C next. Okay, so you're given this function, 7 over 3x to the negative 2. I got to get rid of that negative power, so that's isn't that really just 7/3 times x squared? Again, as you get rid of the negative exponent, you got to move it to the opposite floor. Now we can do the derivative, power rule. 2 multiplied by that, and then reduce the power from 2 to 1. Simplify. 7 times 2x is 14x, and 3 on the bottom. Finally, let's look at the example I wrote in on the bottom. If your function was 9x to the 4th, the derivative, we don't have any negative exponents, so we can begin right away here. Take 4, multiply it by the quantity, reduce the power by 1, simplify. 9 times 4 is, so this is, I don't know, this is probably going to become one of your favorites too. When you realize how long that would take to do those by doing them the way you had to do them today, you are you will be incredibly thankful for the power rule.
On a test, how will we know whether we have to do it the long way or the shortcut way? Will you tell us?
I'll come right out and say it. The long way would be introduced as such. Find the derivative using the limit of the difference quotient. That's the long way.
Okay.
If I don't say that, go ahead and use the shortcuts.
Okay.
Yep, good question.
Thank you.
You're welcome. Anyone else? Comment or question? All right, let's go to the next. Now, you know that we had a couple, limits we had to memorize for sine and cosine? Well, you need to memorize these two definitions too. So the derivative of the sine is the cosine, and the derivative of the cosine is minus the sine. There's a proof in the book, but I'm not going to go through that right now. So those are pretty simple. Just got to know them. The derivative of the sine is the cosine. The derivative of the cosine, negative sine x. All right. So let's apply function. What's the derivative of 2 sine x? Well, we got a constant out in front as a coefficient. We can ignore that. What's the derivative of the sine? The cosine. So that coefficient just stays there. And the answer is 2 cosine x. B, sine x over 2. Well, we can get that constant out by calling that 1/2 sine x. Same thing. Now, ignore the constant. What's the derivative of the sine? Again, it's the cosine. All right, so the answer is 1/2 cosine. And here, either one of these is correct. You could either have this for an answer or this. I'm okay with either one of those. Okay, you don't have to change it to cosine x over 2. Part C, x plus cosine x. Okay, so we know that when you have a derivative with a sum, you can just find the derivative of each part. What's the derivative of x? Power rule. It's x to the first. Take the power, bring it down, multiply by 1, reduce the power by 1. The power reduced is, so this becomes 2x to the 0 power. And x, I'm sorry, it's my pen. Let me try that again. So this is really x to the first. And when you reduce you bring that down, and then you multiply by x and reduce the power by 1, you have this. And what's x to the 0? 1. And what's 1 times 1? 1. So that's where this comes from. The derivative of x is 1. And the derivative of the cosine is minus the sine. We just had it up above there. There it is. And so that one's done. And then part D, cosine of x minus pi over 3 sine x. So what's the derivative of the cosine again? It's minus the sine. All right. Here again, we have it right here. And we got a constant out in front. We don't have to do anything with that, do we? No. And what's the derivative of the sine? The cosine. So just leave that. I mean, there's no simplifying to do there. Any question or comment on any of these that you see in front of you? Okay. And this may be your all-time favorite. The derivative of the natural exponential function e to the x. Don't do anything. The derivative of e to the x is itself e to the x. Another reason that e to the x is really a special function, like I was trying to present to you a couple weeks ago. So this is the only function that is its own derivative. So it's kind of like the only number that's its own reciprocal is 1, right? What's the reciprocal of 1? 1. There is no other number that has a reciprocal that is itself. Likewise, there is no other expression other than e to the x that their derivative is exactly what you had. Okay, so this is really, I guess, the ultimate in laziness with derivatives. It's awesome. So here we go. Let's take some examples here. Example A. 3e to the x. So we know what to do with e to the x. That's just e to the x. And what do you do with a constant in front? Nothing. So the answer? It's exactly where you began. All right? Now look at part B. So here we have a combination between e to the x and x squared. So e to the x, we already know what to do with that. That's going to be itself. That's right here. And what's the derivative of x squared? 2x. So again, no problem. And finally, we have part trigonometry, part natural exponential function. What's the derivative of the sine of x? Here's the original problem up here, up on the right. Sine of x minus e to the x. Well, the derivative of the sine is the cosine of x. And the derivative of e to the x is e to the x, so it's just cosine x minus e to the x. These rules are wonderful, aren't they? I mean, they're quite easy compared to what we had to do for today. All right. Questions, comments? So that's really the end of the rules. Now we're going to talk about sample problems and another important concept here. It's called rates of change. Okay. So there's two kinds of rates of change. There's an average rate of change and there's an instantaneous rate of change. Average means over an interval from point 1 to point 2. And that's just slope. Change in y over change in x. You've been doing that since, I don't know, sophomore year of high school or before, maybe freshman. That's nothing. When you're asked to do an instantaneous rate of change, well, that's your derivative, right? If you can find a derivative, you've got the formula for the perfect rate of change at any value x. So, but keeping those two separate, average rate of change and instantaneous rate of change, that can be a challenge for students. Let's just take a look at this example here. So from the book, they have somebody dropping a billiard ball from 100 feet up. Okay, so we got the picture. And then here you see the equation for dropping a billiard ball from 100 feet up. S equals negative 16t squared plus 100. The 100 represents how high the ball is. And the negative 16 is, that's gravity. And it's negative because it's pulling downward. Okay? So, here's the first part. Find the average velocity over each of the time intervals. Average velocity. So you got to have 2 points. Now, if you look at the way the problem is stated, you see that that's an interval. That's not an ordered pair. That's an interval from 1 to 2. Well, if it was 1, what's the y coordinate for 1? Just go back up to the top line here. Plug in a 1, and you get negative 16 plus 100, which is 84. So in other words, whoops. So in other words, at 1, the y coordinate is 84. Okay, and then at 2, what would that be? 2 squared is 4. 4 times 16 is negative 64. Negative 64 plus 100 is 36. So now we've got 2 ordered pairs. How do we find the average rate of change? Find the slope. And you'll see that's exactly what they do right here. They call this one 0.2 and this one 0.1. So y2, 36, minus y1, 84, over x2 minus x1. And here is the average rate of change from 1 second to 2 seconds. Let's just look at one more. The second one says What's the average rate of change over that interval? From 1 to 1 point to 1.5. Well, again, we already know 1, that's 184. And the other point is 1.5. Whoops. I hate that when this thing just goes berserko. Wow. I don't know how I'm going to get rid of that. Hang on a minute. There we go. Whoop. Nope. Wow. Anyway, I can't seem, if I bring the pencil back, it shows again. So so the 2 points are 184, and when you plug in 1.5, it's way at the bottom of the screen down there. When you plug in 1.5, you get 64. So 184 and 1.5, 64. And then when you do the slope formula, it's way down there at the bottom. You wind up, so this time the answer, yeah, I'm not going to try turning on that squiggle again. But anyway, so the bottom line is when you're finding average rate of change, you're going to need to find two sets of ordered pairs and then simply perform a slope. That's it. Okay, now let me change slides. Maybe that'll help. We'll come back here again. Yeah. Okay, so what would you do if you were to find the instantaneous? Oh my gosh. Okay. Wow, this thing has gone totally berserko. Okay, well, anyway. What would you do if I asked you to find the instantaneous rate of change? Well, now you would just take the function negative 16t squared plus 100, find the derivative, and then find the derivative at whatever point you want. All right. We're going to have another example of that later, and hopefully that I won't have this problem with my... Yeah, it doesn't seem... Okay, doesn't look like we're going to get anything here. Okay, let's go to black. Okay, well, all right, we got it working. Number 8, find the derivative. Real easy, 3 over x to the 7th. You got to get that x to the 7th out of the denominator, because at the moment I haven't shown you how to take the derivative of a division problem. That's coming, by the way, that's coming tomorrow. But anyway, what's another way to write 3x over x to the 7th? 3x to the negative 7. Now apply the power rule. Negative 7 multiplied by 3 is negative 21. Now take the power and reduce it by 1, x to the negative 8. Not done because we have a negative exponent in our answer. Just rewrite it. Okay, let's take a look at 28. They say something about a table. I don't have any table here, but we can still do this. So here's your function, pi over the quantity 3x squared. We need to take, so not only the x is squared, but also the 3 is squared. So the next step over to the right here is we need to take 3x and multiply it by itself. So now we have pi over 9x squared. Well, pi and 9 are constants, so we can pull those off to the side. And isn't 1 over x squared the same as x to the negative 2? Okay, now do the power rule. Take negative 2, multiply it, negative 2 pi over 9, take the power, reduce it by 1. Don't answer with a negative exponent. Final result, negative 2 pi over 9 pi cubed. Let's take a look at 29 too. Square root of x over x. How are we going to write that? Well, we go to the fractional powers. The square root of x is x to the 1/2. And then x is x. By the way, how did I go from here to here? I'd like somebody to answer that, please.
Well, since the x on the bottom is x to the negative first, you can subtract the exponents because they're divided.
That's correct. And when you subtract 1/2 minus 1, you get negative 1/2. By the way, is that the final answer? No, we just, all we did was simplify the problem. So now we can use the power rule, negative 1/2 multiplied out in front, take power, reduce by 1. So I got this negative 1/2 x to the negative 3/2. That x to the negative 3/2 goes on the bottom to make it x to the positive 3/2. Is that the same as writing this? Yes, but why not, I mean, bring them together in this format. Either of those is correct. Yeah. All right, 32. So here's more like yesterday. Find the slope of the graph of the function at the given point. Not the equation. Actually, this is still a little bit short of what they asked you yesterday. So find the slope of the tangent line at the point 4, 1. So slope, we need to find the derivative. So I rewrite 2 minus 4t. 2 minus 4 over t is 2 minus 4t to the negative 1. The derivative of 2 is 0. The derivative of this is the power rule. Negative 1 times negative 4 is positive 4. Reduce power by 1. Write with positive exponents. Now, what's f prime at 4, which is the point we know we have? So you plug in a 4, 4 squared is 16. 4 over 16 can be simplified to 1/4. Slope of tangent line at the point 4, 1 is 1/4. I feel a little bit lost with you guys not responding, so I'm just pausing to make sure somebody doesn't want to ask about something.
Why do you only solve for the 4 and not the 1?
Okay, you're probably yesterday the question was find the equation of the line going through the point. Here, you notice it just said find the slope of the graph. So simply because the directions don't ask us to find the equation. In this one, just the slope. We could go on and say, all right, the equation must be y equals 1/4 x. And we could have gone on and found that, but they didn't ask for it. All right, number 38. Here again, only find the slope of the graph. Okay, so our function is negative 4 e to the x. Oh, this is going to be an easy one, right? What do you do with the constant? Ignore it. And what's the derivative of e to the x? E to the x. So what's the derivative? Negative 4 e to the x. Now the question is, what's the derivative at 1? E to the 1 is e. Negative 4 times e. There you go. That's your slope. And if you're wondering, there, e is what, about 2.7? So, You could actually get a value, but that's the way we want to leave it. I think we got an equation coming up here. No, this is another derivative. Okay, there's something different about this problem. How are you going to find the derivative of a division problem when I haven't told you how to do it? We haven't learned the quotient rule yet. Well, how do you handle a problem where you have three things on top divided by x? Isn't that the same as each term on top divided by x and being added together? Now, you would probably regard this step as kind of primitive, going backwards. I'll agree, but that's exactly what that means. When you divide by a monomial, each term in the numerator is divided by that. So why did I do that? Well, what's 4x cubed over x? 4x squared. What's 2x over x? 2. What's 5 over x? Well, we could write it like this, right? 5 times x to the negative 1. Now we can find the derivative. 4x squared, power rule, 8x. 2 is a constant, goose egg, gone. The derivative of 5x to the negative 1, negative 5x to the negative 2. So even when you have a division problem like this, without the rule we're going to learn tomorrow, we can still do that. Again, questions? Another just plain derivative. We're finally, by the way, you notice the directions way on the bottom of the page here. We're going to be getting one where it says find the equation of the tangent line, which is more like what we did today. So we'll do that next. But 50. Find the derivative. 2 over the cube root of x plus 3 cosine x. So 2 over the cube root of x, we could rewrite that as 2x to the negative 1/3 power. And 3 cosine x, that's fine. Just let it be. Now, what's the derivative? First part, power rule. Negative 1/3 multiplied by 2, negative 2/3. Reduce power by 1. Careful. Negative 1/3 minus 1 is negative 1 1/3, which is negative 4/3. What's the derivative of the cosine? Minus the sine. So this becomes minus 3 sine x. And then just rewriting it so we have positive exponents. I didn't say anything about the, how do you, if the derivative of the cosine is minus the sine, what's the derivative of 3 cosine? You don't do anything with the coefficient, just minus, it's still there. It's just that we got to put the minus because the cosine derivative is minus the sine. Okay, now finally, here's where we're going to find the equation. So this is finally like the ones we did yesterday or today, but this time we're going to, we're obviously going to use our shortcuts. Okay, so here's our function, 2 over the 4th root of x cubed. 2 over the 4th root of x cubed. That can be rewritten as 2 times x to the negative, because it's in the denominator, negative 3/4, right? 3 is the power, 4 is the root. Now, what's the derivative of that? Negative 3/4 times 2, negative 3/2. X reduced power by 1, negative 3/4 minus 1, negative 1 3/4, negative 7/4. And now, because we know the point here, it says, what is it at 1? First, so now take the derivative at 1. 1 to any power is 1. So it's negative 3/2. So now we know the slope of our tangent line. And then you know, you can plug in the whole point, 2 for y, 1 for x, and you can solve for b, y-intercept. So this is the closest to the kind of thing you were doing for today, but of course we can use shortcuts. Questions?
I'm a little bit confused on how you got 2x to the negative 3/4 from the 4th root of x cubed. Can you go over that?
Yeah. So if here, let me write it on the side here. So if I asked you, what's the 4th root of x? Would you agree that that's x to the 1/4 power? It's the definition of root and a fractional exponent. You know those are the same, right?
Yeah.
Okay. So now I've got the 4th root of x cubed. So if we put a cube on here, so now you've got, now I got to change this. So let me erase. So now I've got x cubed to the 1/4. And the rule for that is keep the base and multiply the exponents. So the 4th root of x cubed can be written like this. So all I did is, because we're dividing by that, the exponent is negative.
All right. Thank you.
You're welcome. Okay, let's go to number 94. Yeah, so here we go with rate of change again. I'm glad we have a second one of these. All right. So it says find the average rate of change for part 1. Compare this average rate of change with the instantaneous rates of change at the endpoints. Okay, so here's our function. F of t equals t squared minus 7. Okay, and we're supposed to do it over the interval from 3 to 3.1. That's what those square brackets, that's an interval. So at 3, what is f of t? So if you plug in 3, 3 squared is 9, 9 minus 7 is, so 2 is the y coordinate, correct? So at the left end, it's 3 comma 2. At the right end with 3.1, 3.1 squared minus 7, you come up with 2.61. So you see now I have 2 ordered pairs. How do you find average rate of change? Slope. And that's what I did right here. So, and by the way, the slope, 6.1. Okay, so there's my average rate of change over that interval. Now, the second part, it says compare that to the instantaneous rate of change at the 2 endpoints. So, first of all, what's the derivative of this function? T squared minus 7, it's just 2t, right? Because the derivative of t squared, use the power rule. The derivative of the constant 7 is nothing. So there's my derivative, right? Right here is my derivative. Okay. Now the question is, what's the derivative at the first endpoint, 3? That's simple. 2 times 3 is 6. And what's the derivative at 3.1? 2 times 3.1 is 6.2. So here's the left endpoint. That's got a slope of 6. At the right endpoint, we have a slope of 6.2. And the average rate of change, notice, is, oh yeah, it's right between them. It won't always be, but here it is, 6.1. So that's what they want to do. They said, compare this. So that's what we've just done. We compared the average rate of change along with the instantaneous rate of change. Very important that you guys remember average rate of change, slope. Pick two ordered pairs, just perform a slope formula. Instantaneous rate of change, derivative. And you can do that at 1 point. The derivative at 3, the derivative at 3.1. We only need 1 point. Yeah, here's another one I just made up. Let's say we have the function x squared. And part A says, find the average rate of change over the interval from 1 to 3. So at 1, what's the y coordinate? 1 squared is 1. So the first point is 1, 1. At 3, what's x squared? 9. So my two ordered pairs are 1, 1, 3, 9. What's the average rate of change? I just perform a slope formula. And it turns out to be 4. Okay. Part B, find the exact rate of change at the endpoints of the same interval. So first we do a derivative. What's the derivative of x squared? 2x. Okay. What's the derivative at the left endpoint? 1. Plug in a 1. 2 times 1 is 2. What's the derivative at the right endpoint? 3. Derivative 2 times 3 is 6. So here again, here's our exact rate of change in the beginning, exact rate of change at the end, and up here is the average rate of change. Okay. So let's do this one too. There's another one with rate of change. So the function is sine x. The interval is 0 to pi over 6. All right, at 0, what's the sine of 0? Trig question. 0, right? What's the sine of pi over 6? 30 degrees, 1/2. So here's my two sets of ordered pairs. Okay. Do the slope, and I wind up with 1/2 divided by pi over 6, which turns out to be the final average rate of change right there, 3 over pi. Okay, now what's the derivative of the cosine? I'm sorry, what's the derivative of the sine? The cosine. What's the cosine at the left endpoint of 0? 1. What's the cosine at pi over 6? Square root of 3 over 2. So, the bottom line is average rate of change. You'll need two ordered pairs, and you're going to perform a slope. If you're asked to do an exact rate of change or instantaneous, another name for the same thing, you'll need your derivative to do that. All right. There's your 3-2 work. And I'll take any questions. Okay, thank you. I appreciate it. Have a good day, and I will see you tomorrow.